Hello and welcome to Beginning Engineers. Today I'm going to be discussing acceleration versus velocity. There is a difference. I touched on it some in my statics and dynamics video. Today I'm going to go a little more in depth on it. Acceleration is the rate of change of an object's velocity. It's not velocity. It's not how fast something is moving. It's how much it's changing in velocity. Acceleration is the net result of all forces acting on an object. It's Newton's second law of motion. Force equals mass times acceleration. It is a vector, which is why it was covered in my statics and dynamics video. And a vector has magnitude and direction. So you can't just say you're accelerating at a certain pace. You can't say I'm accelerating at 30 feet per second. You have to give a direction. At least when you're trying to be technical about it, you do. It's interesting to think about it though, because a lot of people mix it up with velocity, thinking it's very similar. And there are similarities, of course, but ponder this. Even if you are traveling 1 million miles per hour, if you're not changing speed, you have zero acceleration. You have no acceleration. So high acceleration doesn't necessarily mean you're moving fast. If you continue that acceleration, you will be moving fast, but acceleration is not speed. It's a change in speed. The standard unit for acceleration is meters per second. That's the reason the S is squared. It has a little 2 above it. That means for every second. In America and a few other places, it's feet per second. So when I say derivative, I'm going to touch on calculus briefly, but a very simple overview. Look at the picture I have on this slide. Let's pretend that line represents velocity. If you take any point on that line, you would have a singular velocity. That is that object's velocity at that point in time. Now in calculus, the derivative of that line at a certain point is a tangent line that only touches it at that point. So pick any point on that line and draw a line that just touches that point. It would be called a tangent line. The slope of that line would be the acceleration of that object at that exact point in time. So if that black curving line is velocity, you see that the velocity of the object is changing. It's increasing then decreasing. So the acceleration would change as well. It really is derivatives all the way down. So you take the distance function and you derive that. So the same way that we derived velocity to get acceleration, velocity itself is the derivative of the distance function. That makes sense. Velocity is the speed. It's how fast you're moving. And how fast you're moving is how much distance you're covering in a certain amount of time. So take the position formula, wherever you're at, and based on how much you change position and a certain amount of speed, that's your time. 30 miles per hour means you're traveling 30 miles in 1 hour. You're traveling the distance of 30 miles in the time of 1 hour. And that's a velocity. But what if you speed up to 45 miles per hour halfway through that drive? Well, that change in velocity is an acceleration. It's a derivative. It's not just the distances that are changing, it's the speed at which you're covering that distance. That's changing. So I hope that makes sense, where acceleration and where even velocity come from. Here's some fun facts that hopefully help the idea of acceleration and the idea of velocity stick in your brain a little better. Gravity, a lot of times noted as a G, accelerates objects at 9.81 meters per second every single second, and 32.17 feet per second. Those are the same. It's just converting metric to English, metric to American. That means, say you fall for 5 seconds. That means you're traveling around 50 meters per second at the end of that 5th second, or 160 feet at the end. At 4 seconds, you're traveling a little bit less, so your speed is changing as you fall. This one really blew my mind, but I think it speaks to Newton's second law and how the world works. So despite what may seem natural, it does not take energy to be in movement, only to start that movement. If you have an object that's traveling at a certain velocity in a vacuum, so there's no forces, no air, nothing acting on it, you don't have to give it energy to keep it moving. And that seems weird because living on Earth, we're so used to forces working against us to slow us down. Things are pushing back on us. But, according to physics, in reality, velocity takes no energy. Now, getting to that speed, of course, but once you're at that speed, it's just a state. You're in a state of motion. It's not like it absorbs energy somehow, and that's pretty interesting to me. The speed of light, people love talking about that, is 300 million meters per second, roughly. That is so incredibly fast. As you get closer to the speed of light, things change so dramatically, we don't really have an understanding of it because we've never gotten that close to that speed. The International Space Station, which orbits the planet very fast, is only moving around 5 miles a second, whereas the speed of light is close to 200,000 miles per second. So these are speeds we have never come close to getting near. But one thing I like, touching on general relativity, as you get closer to the speed of light, a lot of weird things happen with mass and size, and my favorite one is time. So if you were able to travel at half the speed of light, you would only age at 86% the normal speed. And I believe that's going to make things interesting for us, the human race, as we become a spacefaring civilization. So you might be on a ship someday, headed for another planet, and it's a 10-year journey. But let's say that ship was traveling half the speed of light. To you, it would only seem like 8.6 years. Whereas to everyone else, not moving that fast, it would seem like 10 whole years. And that's a huge advantage to traveling long distances. Thank you so much for watching this video. I hope you have an understanding of what acceleration is, how it's different from velocity, and really where they both come from. If you like this video, please subscribe. I'm going to do a few engineering videos in the summer of 2016 talking about tons of different engineering concepts. Have a good day!